Snowdonia was an ideal location to illustrate the impressive landscapes that cold environments can create, giving the scenery we see today. The processes of erosion, transportation and deposition that occurred over a series of glacial and interglacial periods were and continue to be responsible for the landscape we see before us. These alternating periods of glacial advance and retreat most recently happened within the Pleistocene period, which incorporates from 2.6 million years ago to 11,700 years ago. Most of what we witness today is a result of the Devensian glacial period and the following Flandrian transgression. The Devensian was the glacial period 18 to 85,000 years ago, in which sea level was 100 meters below today's level. The Flandrian transgression was the following event, which was the most recent period of glacial retreat, with sea level rising once again, peaking around 5,000 years ago. On our expedition, we witnessed a range of features that have come about because of these events in the past. On the first day, we were able to see a corrie, or as they are referred to in Wales, a quim. These are deep bowl-shaped depressions located at mountain heads that are the sources of valley glaciers. The main cause of these is the rotational flow of the glacier under gravity, which is lubricated by basal meltwater. The rotational flow quarries the bedrock, arming the ice with rock debris so that it abrades the bedrock and lower parts of the basin. What we could also see here was a proglacial lake, which develops where meltwater was blocked at the margin of glaciers and is gradually added to by streams and overland channels. As we approached Berabach on the first day, we began to see an increasing number of misfit streams. They are termed this because they are deemed too small to have eroded the valley in which it flows. In this case, they exist because glaciation has modified the landscape by creating glacial troughs. The rivers that occupy such valleys after the ice has retreated are not in proportion with the size of the valley. Increasingly, we witness the anthropogenic influence on the landscape, and particularly with water features. At the end of the first day where we set camp was the reservoir of Llyn, which has a dam originally built in 1881 to increase its water capacity, but has since been altered several times. The reservoir provides water to the town of Llandudno. Llyn is a good example of a tarn or cirque lake, that is the remains of a corrie. The scouring of the bedrock must have been intense, as the deepest part of the lake is 58 meters, a considerable depth for a lake this diameter. Today it is overlooked by the high cliffs of Garna Duchaf. After a tough start to the second day, we were given a better view of the curved lip of the Cirque Lake where we had camped. On our way to another lake, Llyn, we were able to see a number of truncated spurs. These are ridges that descend towards a valley floor from a higher elevation that ends in an inverted V-face and was produced by the erosional truncation of the spur. Llyn had a 35 feet high dam constructed at the eastern end in 1911 to supply water for the Dolgarrog power station. Due to alleged corner cutting, the original contractor abandoned work on the dam. The lake was the scene of a terrible disaster in 1925, following 26 inches of rain in just 5 days. The dam burst on the 2nd of November. The water flooded down to Kurdi Reservoir, which also burst, causing millions of gallons of water to flow down onto the village of Dolgarrog, which demolished the aluminium works and a row of cottages in which 17 people were consequently killed. A new power station was constructed at Dolgarrog in 1925. The dam now stands high and dry above the lake. An examination of its structure reveals that the foundations were insufficient. A mile north of this lake, we arrived at Llyn Cawlyd. This is a reservoir providing water for the towns of Conway and Colwyn Bay, and has a 30-feet dam at its northeast end. Llyn Cawlyd is the deepest lake in Wales, at 70 metres at its deepest point, measures 2 miles long by 1/3 of a mile wide, and lies at a height of 355 metres above sea level. On our way down from the lake, we were often adjacent to a number of rivers and streams, a lot of these being misfit streams. The reasonably fast drop in elevation meant that the vertical erosion was prevalent, and we would often see a number of waterfalls in which the water had eroded the underlying weaker rocks. In the region we were in, this is most commonly sandstone underneath the igneous rocks. Another significant notable feature was the decreasing size of bedload as we descended. Closer to the source we saw larger boulders with many braided streams, but further down we went, the bedload became much smaller and rounder, and the water much less turbulent. Our campsite following the second day overlooked another two lakes called Linau and Mimbir. Strictly speaking, this is one lake, originally called Lim Mimbir. It has a maximum depth of 30 feet and about 3/4 of a mile long in total. A delta has built up midway along the north shore, and this has to all purposes cut the lake in two, hence the plural name. The lake was used for fly fishing and sub-aqua courses in the 1960s, and is still used today as a canoe training resource by Palazzi Brennan and other local education authorities. On the morning of the third day, we passed a canoeing centre on the edge of the lakes. We then found ourselves walking alongside much wider river channels with considerably smaller sediment load and also much less turbulent flow. The gradient of the river was very much shallower until we reached a series of small waterfalls further downstream. These waterfalls again would have been formed because of the erosional undercutting of the water through abrasion and attrition, which would have weakened the underlying rock and then consequently would have been unable to support the overlying igneous rocks. This process is what can cause the waterfall to retreat up the valley, creating what is known as recessional gorges. The depth of the waterfall will also be continuously increased by the ongoing erosion within the plunge pool. As sediment is eroded and falls into the plunge pool, this will increase the rate of erosion. The series of falls we passed here were known as Swallow Falls. It is on the Afon Lugwi near Betsy Coed. It was suggested in 1899 that the falls could be used to generate electricity for the nearby village of Betsy Coed, as well as overhead lighting for the falls. In 1913, the second Lord Ancaster, the landowner, gave the Swallow Falls to the local council, who decided to charge for visiting it in order to pay off some of the £15,000 debt incurred through the installation of water and electricity supplies to the village. Once the debt of costs of installation was cleared, the parish retained the fee, resulting in Betsy Coed having the lowest rates in the country. The cheap water and electricity rates ended after local government reorganisation in 1974. On the final morning we came over Afon Ledder, which is the second major tributary of the River Conwy. The point at which we saw the river was at the Roman Bridge. This stretch of the river is supposedly a popular spot for water activities such as canoeing. On our expedition, we witnessed a range of geological and water features that have come to look the way they do today because of the events that occurred in the Devensian period. We have also come to realise how these have been used both successfully and unsuccessfully by man for economic, social, and recreational use.